Pasteur's original mixture of plus and minus tartaric acid did not rotate plain polarized light. This confused him for quite a bit. How could he get things that rotated light from something that did not? But his original mixture was an equal mixture of the plus and the minus enantiomers. One of them rotated light in one direction, the other rotated light equally in the opposite direction, so one cancels the other's rotation of light. Okay? That's called a racemic mixture. Right? Racemic mixture is 50-50, the plus enantiomer and the minus enantiomer. So we can denote a racemic mixture as a plus-minus. So if I said plus-minus tartaric acid, I have an equal amount of one enantiomer and the other. If I drew a flat chiral molecule, I would assume that we would have a racemic mixture. Right? So if I drew just a C with A, B, C, and D drawn flat like that, showing no stereochemistry, I'm not specifying one enantiomer or another, so I'll assume that I have an equal mixture of both enantiomers. Now, mesotartaric acid is a pure substance, has only one isomer that's achiral. It does not rotate light because it's achiral. Plus minus tartaric acid contains a racemic mixture of two chiral enantiomers in equal amount. So neither of these rotate light. However, the plus minus tartaric acid, if the two enantiomers are separated, okay, it's called being resolved. A racemic mixture can be resolved. Pasteur, he was sort of lucky that the two different enantiomers crystallized differently, but a lot of times if you react them with a single chiral reagent, you can separate it. So separating the two enantiomers, each of them would rotate light in opposite directions. So I have a mixture of R and S together, okay, all together. So does not rotate light. If I react those with a chiral reagent, this is R-phenylethylamine. There's a reaction they can undergo, but you can imagine the combination of each of those. I can have R reacting with R, okay, or I could have the S enantiomer reacting with the R. I end up with RR and SR. Okay. R and S came from the original racemic mixture, but the chiral reagent was only R. So what I get are two diastereomers, and remember, diastereomers have different properties. I can separate those two by chromatography like we did in lab. One of them would be more polar than the other, for instance. I could, if it was a liquid, I could distill them because one will have a different boiling point than the other. I could not do that with just the enantiomers because they will undergo all the same chemical reactions. They will separate just the same on chromatography. They'll have the same boiling point, same melting point, and so on. But by making two diastereomers, then they can be resolved that way. And then you could just remove that reagent and you'd have separate samples of the individual enantiomers that would rotate light in opposite directions.